And for the unit circle, well, unit circle means that the radius is 1. Okay, so the radius is 1. So what we're seeing here is a circle that has radius 1. In fact, you can tell that from the origin, meaning from 0, 0 up out into this point, which is on the edge of the circle, that has coordinates 1, 0. That's because we went 1 in the x direction, 0 in the y direction. So that means that distance is 1. Okay, so now let's tie it back to what we learned about sine and cosine specifically. Cosine, according to this alternative way of thinking about the trig functions, is x over r, right? Where x is the x coordinate of the point and r is the distance from the origin to the end of the terminal side. Well, if the terminal side, let's say that we're considering the terminal side for an angle that measures 30 degrees. So that one there. And here is our initial side always on the positive x-axis, right? So let's say that I'm considering this terminal side. What is this distance? If this is a unit circle. What did we say was the distance here?
1.
Is it 1?
Yeah, again, it's 1. So if the distance here is 1, and this is a circle, well, from the origin to any part of the edge of the circle, it's going to be 1. So r is going to be 1 regardless of what point you pick on the edge, right? Because the radius is 1. So what that means then is that cosine of angle theta is x on the unit circle. Okay, so it's exactly the x coordinate on the unit circle. Similarly for sine, if we take a look at sine of theta, by the definition that we just saw, it's y over r, but now the radius is 1, so that means that we get a y over 1. Or in other words, sine of theta is always the y coordinate of that point. So looking at this point, if I have x and y coordinates for it, the x coordinate will be cosine theta, will correspond to cosine, and actually theta here has a specific value. It's 30 degrees. So let me replace that in. Okay, it would be cosine of 30 degrees for the x, sine of 30 degrees for the y. Okay. And, well, we actually know how to find sine of 30 and cosine of 30. Okay, in fact, what we're going to do here is we're going to remember what those values are, as well as what are the sine and cosine of 45 and sine and cosine of 60. Okay, so if you have a sticky note, just go ahead and bring it out, or a scratch sheet of paper, so that we can have this handy somewhere on the side. I'm going to draw a 30, 60, 90. Okay, so let's see, I'm going to draw the bottom angle as my 30 and then this top angle as my 60. So 30, 60, and 90. Now in a 30, 60, 90, the opposite side to 30 is always the smallest side, which we call x. The side opposite to 60 we call x radical 3, and the hypotenuse is always 2x. And twice the amount of the smaller side. So if I want to find out what is cosine of 30 degrees, and well, cosine of 30 will be the side that's adjacent. So adjacent would be x radical 3 over hypotenuse, which is 2x. And actually, let me write out the definition because I want to make sure that we all remember where this is coming from. This is coming from the definition, cosine is adjacent over hypotenuse. So the side that's adjacent to 30 is this x radical 3 over hypotenuse, which is 2x. And what happens to the x's?
They cancel out.
They cancel out, right? They cancel out. So these are gone. We get square root of 3 over 2. So cosine of 30 for any triangle is going to be the square root of 3 over 2. Let's do the same for sine. Any questions here with cosine before I move on? Okay, let's take a look at sine. Sine is opposite over hypotenuse. Well, opposite to 30 is x. And actually, let me again write the definition. It's opposite over hypotenuse. Okay, opposite to 30 is x. Hypotenuse is 2x. And again, these x's are going to cancel out. So we're going to end up with a 1 over 2. So that means that sine of 30 degrees will be a 1/2. Okay, so let's refer back to unit circle now that we have these values. For 30 degrees, this point will have an x coordinate that's the same as cosine of 30 by what we found up here. And we just calculated cosine of 30. Cosine of 30 is going to be square root of 3 over 2. So this first coordinate is square root of 3 over 2. Excuse me.
I have a question.
Yeah.
For the cosine of beta, which is equals x over r, how did we determine that the answer was x over 1?
The reason why is because this circle has a radius of 1. So regardless of which terminal side we're considering, from the origin to a point on the edge of the circle, that distance is always going to be 1.
Okay.
So that's where it comes from. So any angle on a unit circle will have r equals 1.
Okay, and then one more question. The calculations that we're doing on the post-it, is that just like an example, or is that an actual, like, is that the 30 degrees that we're doing?
So this one is 30 degrees with what we're working here.
Okay.
It applies to any triangle that has that 30 degrees. So regardless of what the sides are, the cosine of 30 will always be square root of 3 over 2.
Okay.
Alrighty.
Thank you.
Okay, yeah, no problem. Okay, so then y, if cosine of 30 was radical 3 over 2, that's our x. And then sine is the y, so sine of 30 was 1/2, which means that this coordinate is going to be 1/2. And we can actually repeat that process for 45 degrees. So let me just erase this terminal side because now we're considering an angle that measures 45 degrees. So it opens that way. That's 45 degrees. And for that terminal side, this point, maybe right now we don't know what it is. It's just x comma y. And I'll actually leave myself a little bit more room because eventually we're going to replace with numeric values. Okay. And according to what we just saw here, the x will be cosine of the angle. So it'll be cosine of 45 degrees. And the y will be sine of the angle. So it'll be sine of 45 degrees.
Could you explain one more time why the x corresponds with cosine and the y with sine?
Yeah, so from page 2 at the top, when we were looking at the definitions or the formulas that we derived on page 1, we saw that sine was y over r and cosine was y over r, where r is the length of the terminal side, right, which we can also find in this way. But r is the length of the terminal side. Let me actually write that here. And just to show you from the diagram on page 1, I'm going to go ahead and flip this over. Yeah, but if you take a look at page 1 where we first defined R, we said R is going to be this hypotenuse, which is also the terminal side. So that terminal side on the unit circle, this measures one unit. Yeah. So if I take that and I rotate it so that this is my terminal side now, R is going to be 1 because the length of the terminal side is still 1. So in the definition, cosine theta is x over r. R gets replaced by 1 so that we end up with x over 1, and then x over 1 is just x. And so that's how we get cosine equals x.
So
Similar-
the terminal side will always be 1?
On the unit circle, yes.
Got it. Thank you.
Yeah, no problem. Okay. So for 45 degrees, this diagram that we have here doesn't help us too much, or doesn't help us at all because we have 30, 60, and 90. I'm going to go ahead and draw a diagram that has a 45, 45, 90 instead, so that we can calculate what are sine and cosine. So let's just draw a 45, 45, 90 triangle. Do you guys remember what was the formula for 45, 45, 90? A triangle that looks like 45, 45, 90? What are the measure of the legs?
The X goes on the short side.
Yeah, so X is for both legs because they measure the same, right? This is an isosceles triangle when you have a 45, 45, 90. The hypotenuse, do you guys remember what it was?
Was it radical 2?
Yeah, it was x radical 2. Very good. Yep, x radical 2. So if this measures 5, this also has to measure 5, and the hypotenuse would measure 5 radical 2. Okay. So based on this, if we now try to find what is cosine of 45 degrees, doesn't matter which one of these angles you consider, just pick one and stick with that one. So I'm going to pick the one down here. Okay. Cosine of 45 would be adjacent, which is x. And actually, let me write again the definition. So it's adjacent over hypotenuse. That would be x over x radical 2. And now x's cancel out. We end up with a 1 over radical 2. Now we don't like to have radicals in the denominator, so we want to rationalize that, which means I'm going to multiply top and bottom by a square root of 2. And the final outcome of this would be a square root of 2 over 2. Is this okay? Okay, what about sine of 45 degrees? Again, since we used this angle at the bottom for cosine, we'll also use it for sine. That is going to be opposite over hypotenuse. Opposite to 45, we have x. Hypotenuse will be x radical 2. So it's going to be the same thing, right? Same process. We're going to get 1 over radical 2. We're going to rationalize, and eventually we'll get a square root of 2 over 2. I just didn't write this down, but same thing. So now, now based on that, cosine of 45 is x. So that means that x here has to be radical 2 over 2, because that's what we calculated for cosine of 45. Just so we can erase the x and replace with the number. And y is sine of 45. Sine of 45 is radical 2 over 2. So y will have the same value as x, square root of 2 over 2. Okay, so questions there. All right, and then we'll take a look at 60 now. So we'll erase this terminal side, because now we want to look at an angle that measures 60. So meaning we're going to make it all the way to this terminal side. And again, this point, which at the moment we don't know what it is, x comma y, will be the same as cosine of 60 degrees, sine of 60 degrees. And even though we use this first sticky note to help us find cosine of 30 and sine of 30, I'm just going to use the same diagram to help me find out what the cosine of 60 and sine of 60 are now going to be. So cosine of 60 degrees is going to be adjacent over hypotenuse. Well, here's 60. Adjacent to 60 is x, so we would get x over hypotenuse, which is 2x. So x's cancel out, and we get a 1/2. Now for sine of 60, that would be opposite over hypotenuse. Opposite over hypotenuse is going to give us what? So what would the opposite side to 60 degrees be?
X radical 3
X.
over 2x.
Yeah, good. X radical 3 over 2x. X's will cancel, and we'll get a radical 3 over 2. Good. So now we can replace x and y with these values. X was cosine of 60, so here we're going to have a 1/2. And sine of 60 is y, so we're going to get a square root of 3 over 2 for y. Okay. Couple questions. Where did the x square root of 3 come from? And thank you, Martin, for answering that. Yes, that is a 30, 60, 90 rule triangle. And so this is just basically a formula that all triangles that have 30, 60, 90 angles will follow. Okay. Now to find the other points, we don't necessarily have to be drawing these triangles all the time. So for instance, for 120, I see that 120 has the same, is at the same height as this point of 60. They're at the same height. If they're at the same height, what is true about the what coordinate do they share in common?
A y.
Yeah, precisely the y. So if we were to write the coordinates for this, we would get that the y's are going to agree. We're going to get the square root of 2. Now for the x, well, the distance is the same as this distance for this point, but we're actually going in the negative direction, right? So what would be the x coordinate of this point?
Negative 1/2.
Negative 1/2. Excellent. Okay, so again, how did we get that point? Well, we first noticed that this point has the same height as this point. And height just means vertical distance, right? This vertical distance is square root of 3 over 2 from that point that we're reading. So that means that over here, this needs to have the same y coordinate. Then as far as the x coordinate from the y-axis out into that point, that is an x distance of 1/2, right? That's 1/2. We have that same distance, but going in the negative direction. So this needs to be negative 1/2. What can we say about the point at 135? What coordinates is that? Well, first of all, which point does it mirror? What does it reflect? What point in the first quadrant does it mirror?
Pi over 4.
Yeah, the 45, which is, or pi over 4, good. Okay, so it's mirroring that point there. which means they have the same height, right? And if they have the same height, what does that mean about the y-axis? About the y-coordinate.
Are the same.
They're the same. It has to be square root of 2 over 2. What about x?
It would be negative square root of 2 over 2.
Good. Negative square root of 2 over 2. Excellent. And one more point that we have here on the second quadrant. The point at 150 is reflecting the point at 30. So what coordinates does this point have?
2 over 1.
Well, not exactly 2 over 1 because we still maintain the same height. So it's still going to be whatever this height is. And this height is 1/2. So the y will still be 1/2. But the x will be what?
Negative radical 3 over 2.
Good. Negative radical 3 over 2. Excellent. Okay. So what are we doing here? We're taking these points, reflecting them across the y-axis, right? If you take let's see, I'll use that same string kind of demonstration that we did last time. If I take this string and I measure the distance to that point, that would be the x coordinate, which is 1/2. So up to there, that's 1/2. If I now take that and move it across the y-axis, that distance is also 1/2, but it's going in the, not 1/2, square root of 3 over 2. That's our x-axis. That's our x coordinate. So square root of 3 over 2. And then if I move that over, that's the same distance, but going in the negative direction. So I'm going to get a negative square root of 3 over 2 for x. If we think about the y, okay, what is the y? So the distance from the x-axis up to that y coordinate is 1/2. Well, I have that same distance from the x-axis up to that point of 1/2. So the y remains the same. It doesn't change. Is that okay? You guys have any questions? Now let's try to use that same idea of reflecting the points, but now onto the third quadrant. Now in order to reflect onto the third quadrant, let's say that I'm trying to find the coordinates of the point at the terminal side of 210 degrees. So that one lies, if we take a look above the x-axis, that one lies directly below this point at 150 degrees. So what that means is that in order to make it to that point, I would travel the same x direction as I did for the point at the top. So that means that they're going to have the same x coordinate, which is a negative radical 3 over 2. But in terms of y, we go in the negative direction rather than in the positive. So this one will be a negative 1/2. So just take this point, reflect it over the x-axis. It means you have the same x, but we go down in the y, so it's negative. And what that means is that cosine of 210 degrees is going to be a negative radical 3 over 2. And sine of 210 degrees will be a negative 1/2. Maybe it would have been a good idea if I would have reviewed y. Remember, on the unit circle, we always have that x is equal to cosine of the angle, while y is always equal to sine of the angle. Okay. And that's because the second definition that we learned is that cosine is x over r, where r is the length of the terminal side. But since the length of the terminal side anywhere here is 1, because this is a unit circle, we just get x over 1, which is reduces down to just an x. Okay, but that's the reason why. And I'll move this over because we're going to need this space. Okay, but we can just, we can find that same statement up here. Now let's focus on the point at 225 degrees. which point would I need to look at if I'm trying to find a the reflected point? Which point in quadrant number 2 reflects over to this point?
(120°).
Actually, that would be the reflection of 240, right? If I use my my ruler here, the 240 lies directly beneath the 120. For 225, that one lies directly beneath the 135. Right, so this point is a reflection of that point. And what that means is that they're going to share in common the same x coordinate, right? We're still going in the same x direction. So they'll have the same x coordinate of negative radical 2 over 2. But then the y is going to be negative. Okay, so we're going to have negative radical 2 over 2 as well. All right. And then, as I was mentioning earlier, 240 is a reflection of the point at 120. And we can draw these lines just to kind of visualize that. Which means, again, they share the same x of negative 1/2, but the negative of the y's. So that means that if this is a positive radical 3, this one needs to be negative radical 3. All right. So using that the same process, you find these points, but now we use the points in quadrant 1 to reflect over. So like to find out what are the coordinates for the point at 300 degrees, I'm going to take a look at the point directly above it, which is the point at 60 degrees. And because I need to travel the same distance in the x direction, they're going to have the same x coordinate of 1/2. But then the y coordinate is going to be negative because we go down, right? So this is a negative radical 3 over 2. For 315, we look at the point at 45. So that's the reflection. And that means that we have the same x coordinate, radical 2 over 2, but negative of the y coordinate, so negative radical 2 over 2. And then finally for 30, that reflects down to 330. So it'll have a radical 3 over 2 for x coordinate, the same one, but negative y. So like this. All right. Now having these points is very useful because we can now find out what is, for example, cosine of 300 degrees without necessarily having to draw a right triangle and find the reference angle for it. We can simply go to the 300 and then pick out the x coordinate, and that would be the value. Okay, cosine of 300 degrees is 1/2. On top of that, the unit circle gives us the trig functions of angles that we hadn't previously thought about, like 90 degrees, right? So like if I ask, what is sine of 90 degrees? Well, I would go to the 90 degree, I would look at the y coordinate, and then we would get that sine of 90 as 1. Let me ask you guys this. What would tangent of 90 degrees be? Yes. Can you guys think of any way that we might be able to figure that out from the given information? I'll give you a hint. Look at page, let's see. Look at page 2 of lecture notes week 3 at the top, where we took a look at the second definition of the trig function. What is tangent of any angle according to the second definition?
Y over X.
Good, very good. Y over X. So in this case, if we want to find tangent of 90 degrees, which point would we be looking at, and what would we write as a fraction?
The opposite angle over the adjacent angle, in which case it'll be where the 90 degrees is and where the initial side is.
Okay, good. So we are going to consider the 90-degree angle. Here's what's a little difficult about considering the opposite over adjacent though. When we have a 90-degree angle, it's not possible for us to draw a triangle where this is the terminal side, right? If we had to draw a right triangle with the angle being here, the terminal side would be, or the hypotenuse would be somewhere over here. So we can't quite draw that triangle with this being the terminal side. So instead we consider this definition, the y over x, by looking at 90 and seeing what are the x and y coordinates there. So since the x is 0 and the y is 1, we get a 1 over 0, which is actually undefined. It's undefined. Good. And Kevin, yes, thank you. Exactly. That's exactly what we're doing. So Kevin on the chat mentioned it's y over x, so that means that tan 90 is 1 over 0. And just to verify, I'm going to show you guys what happens when you try to punch it on the calculator. So if I try to take tangent of 90 degrees, that gives me an error. It gives me, I have a domain error. And that's because it's trying to calculate this 1 over 0, which is undefined. Good. Let me ask you guys something else. What would tangent of 180 degrees be? So this is just kind of like extra practice, and I'll write it here.
Would it be? Oh wait, should I answer that, or was it just something to think about?
No, yeah, for sure. Yes, please go ahead and answer.
Oh right, right. It'll be the same thing as within the parentheses of negative 1 over 0, correct?
Very close, except that now we have x for being negative 1 and y for 0. So if we have y over x, that would mean a 0 over negative 1, which is going to be 0 in this case. Yeah. So because here basically the x and y, they kind of flip, right? They're the different values. We get 0. Okay, because now the 0 is in the numerator instead of in the denominator. Yeah. All right. Any questions there? We'll do one last one, and you guys help me out with this. What would cosecant of 270 degrees be? Let's take it step by step. Cosecant is the reciprocal of which function?
Sine.
Sine.
Sine, good. So if we take a look at what is sine of 270, what do we get?
Negative square root 3 over 2.
Yeah, good. So on the chat I see, is it Lee? Or so we get a negative 1, right? Because if we take a look at the 270-degree angle, we have an x-coordinate of 0 and a y-coordinate of 1. And sine is always the y-coordinate, right? So sine of 270 degrees is negative 1. So if we're trying to find cosecant, and cosecant is a reciprocal of this, then we would get 1 over negative 1. Right, which is still just going to be negative 1. So even though on the unit circle we technically explicitly only have sine and cosine as x and y respectively, we can always find any of the other trig functions by using what we know about the second definition. So like in the case of tangent, it's going to be y over x. In the case of secant or cosecant, we would just take the reciprocal of sine or cosine, depending on what they ask us for. All right, so that's unit circle. Let's take a look at some of the other examples on page 4. Good question. So on the chat, there's how for cosecant, how would we do it on a calculator? Excuse me. So on a calculator, you would write it as the reciprocal function, so 1 over sine. If you want to find cosecant of 270, we would write 1 over sine of 270. And that'll give us the -1 that we calculated using the unit circle. But yeah, that's how we do it. Same for secant. For secant, it would be like 1 over cosine. Okay, so let me ask you guys this before I press enter here. What is going to be secant of 270 degrees? So let's go to 270. Here's 270. And I want to find secant. So for secant, we would take a look at the cosine value, right? Cosine of 270 is what? It's 0. Good. So then if we want to find secant of 270, what is that going to be? Undefined. Very good. Because it's going to be 1 over 0, which will give us undefined. Okay, so let's verify on the calculator. I've got 1 over cosine here, which is our secant value, and there it is. It's telling us we have an error because we're dividing by 0. Okay, good. All right, so for example 2, they're asking us to use a unit circle to find each of the following. Let me go ahead and bring half of the circle because I think at least for these first 2, we can use the half of the circle from the last week's lecture video. So for sine of 120, that means we go to the 120 angle, and which of these 2 values is representing the sine, the x or the y?
The y.
The y, good. So that means that sine of 120 is going to be radical 3 over 2. So for part A, sine of 120 is radical 3 over 2. And notice how, having the unit circle cuts down the computations that you have to do. You don't have to look for the reference angle. You don't have to draw a right triangle. You don't have to worry about the signs because it's directly there off the unit circle. You just need to know how to read it. All right, good. Let's take a look at part B, which is secant of 30 degrees. Now, secant of 30 degrees is going to be reciprocal of, so here this is kind of like our side work. It's going to be reciprocal of which function?
Cosecant?
Close, not cosecant, but it does start with the
Cosine.
cosine. Good. So it's the reciprocal of cosine. So what we're going to do is we're going to find out what is cosine of 30 degrees instead. And cosine of 30, that means go to the 30-degree angle. And in this case, read the x coordinate because x is represented by cosine. So that'll be a radical 3 over 2. This is radical 3 over 2. And that means that secant will take this and flip it, right? It'll be the reciprocal. So it's going to be a 2 over radical 3. And we don't want to leave the radical in the denominator, so we will multiply top and bottom by the square root of 3 to rationalize. That'll give us a 2 radical 3 divided by 3. Is that okay? You guys have questions there? All right, and finally we have tangent of 315 degrees. Remember, tangent for any angle is going to be y over x. So that means that for 315 degrees, and I'm going to flip this over for a second so that we can take a look at the 315. For 315, we need to read what are the x and the y? So x is positive radical 2 over 2. Y is negative radical 2 over 2. So we'll write that over here. This is negative radical 2 over 2 divided by radical 2 over 2. And well, these are essentially the same thing, right? It's like if I have a number 3 or a negative 3 up here divided by a positive 3, that's just going to be a negative 1. You have the same thing in numerator and denominator. They divide out to a 1, but I have to keep the negative because there's a negative there. So that would just be negative 1. Do you guys have any questions? Okay. Take a look at example number 3. This is asking us to find all of the values, all of the values of theta in the interval 0 to 360. Let me just ask you guys about these symbols here. So we have a bracket and a parenthesis. Do you guys remember from algebra when you're given a range of numbers? If you have a bracket versus a parenthesis, what did it mean? What does a bracket mean? Remember, it was related to, so like let's say that I have, good, thank you, Lee, that means that it is included, right? A parenthesis means that that value is excluded. So if we were to write this as an inequality, it would be saying that the angle theta can be greater than or equal to 0 degrees and strictly less than 360. Okay, so it could be 0 degrees, but it cannot be 360. All right. So they want us to find all of the values of theta in the unit circle that give us cosine theta is negative radical 2 over 2. Now we could, potentially go and check every single point to see which of these has a negative radical 2 over 2 as an x-coordinate, right? Because we're looking at cosine. But we can, try to be clever about it and cut down the amount of points that we're checking just by remembering some key ideas. Okay, so first of all, I'm going to say, recall that 1, x is equal to cosine theta on the unit circle. And 2, if x is negative, or if the value is negative, if cosine theta is negative, then which quadrants would have a negative x value? Okay, so
it will be quadrant 2 or 3.
Good, very good, exactly. So if x, which is equal to cosine, is negative radical 2 over 2, that means that x has to be in quadrant 2 or quadrant 3, right? Because that's where we have negative x values. So we don't need to check any of these two because it's not going to be found there. It's going to be found either here or here. And so that cuts down, half of the points away. And then we can, pinpoint, well, 135 degrees has an x-coordinate of negative radical 2 over 2, so that's one possibility. And then we can easily reflect that over to the third quadrant and see that at 225 has the same x-coordinate of negative radical 2 over 2. So the two possible angles that can satisfy are 135 degrees and 225 degrees. Okay, so let's go back here. All right. And sorry, let me just be careful here. This is angle theta could terminate in quadrant 2 or 3. All right, so we found those two values, right? Theta could either be what did we say? 135? Yeah, 135 or 225. Any questions there? right, let's take a look at example number 4. For this one, we need to find all of the values again between 0 and 360, including the 0, excluding the 360, such that cosecant theta is -2. All right. This one's a bit, maybe a little bit trickier, just because on the unit circle, we know that explicitly we don't have, secant, cosecant, cotangent. We only have sine and cosine. So the first thing that we should do is try to relate it back to either sine or cosine. Okay, so in this case, which one of the two do we want to relate it back to? What is cosecant related to? Sine. Very good. Yep, thank you, Kevin. So sine theta is related to cosecant in that it's its reciprocal. So if cosecant is -2, that means that sine of theta will be the reciprocal of that. It's going to be -1/2. Okay, so because sine is the reciprocal of cosecant. All right, so now finding the angle that satisfies this equation in the interval 0 to 360 is the same as the angle that satisfies cosecant theta is -2. So we're going to focus on this one. Sine, again, notice, first of all, y is equal to sine of theta, which in this case is equal to -1/2. Now, if y is negative, which two quadrants would that force the angle to be in? Where is y negative?
Quadrants 3 and 4.
Quadrants 3 and 4. Good. So that means that theta is in quadrant 3 or quadrant 4 because that is where y is negative. Okay. So we've eliminated half of the points just by realizing that. So we're going to focus down here. We're wanting a y value of -1/2. So which points have a y value of -1/2?
210 and 330.
Very good. Yeah, 210 and 330. Good. Okay, so that means that theta could be 210 or 330. Okay. All right, and we have one more. Any questions on example 4 though, before we move on? Example 5 is asking us to find all the angles theta in interval 0 to 360 such that cotangent is -1. So, okay. Again, cotangent is not explicitly on the unit circle. And unfortunately, not even the reciprocal is there either, right? Tangent is not explicitly on the unit circle. But what might help us here is the fact that cotangent, if tan is y over x, then cotangent has to be x over y, right? Because cotangent is a reciprocal of tan. So that means that we want cotangent x over y to be -1. So i.e., we want all of the angles theta such that x over y is equal to -1. Now, how does this help us? Well, let's just think about it. If we had to solve for x, for instance, I could multiply both sides of this equation by y. And what that would give us is that x is equal to a -y, right? So we want all of the angles theta such that the point x and y are the same but negative of each other. So they have the same value, but one of them is positive and the other one is negative. The same, I should say, the same absolute value. So that's what we're looking for. Which angles have a point where the x and the y are the same but just opposite in sign? Opposite sign.
Quadrant 2 and 4.
Very good. Quadrant 2 and quadrant 4. If we take a look at quadrant 2, the x is negative, but the y is positive, right? And if we take a look at quadrant 4, the x is positive, but the y is negative. So they have opposite sign. Good. And which points, either these three or from these three, satisfy that the x and the y have the same absolute value, meaning they have the same number?
135 and 315.
Very good. Yeah, 135 and 315, because both of these are the same, right? Radical 2 over 2, radical 2 over 2, but they have opposite sign. One of them is negative, the other one is positive. Same thing down here. So the two angles that we want is 135 or 315. 135 or 315 would satisfy that. Questions here? So for all of these three examples, you can double check your work by plugging the angle back into the equation. So for instance, if I wanted to make sure that cotangent of 135 is, or rather if I want to make sure that 135 is correct, it would need to be true that cotangent of 135 is -1. So on the calculator, just to do it a little bit more quickly, I would type 1 over tangent of 135, because that's the same as cotangent, and we would get -1, which is precisely what's required. Same thing with the 315. If I write 1 over tangent of 315, we also get -1. That means that both of these are correct answers, because plugging them in satisfies the equation. Similarly here, except that for cosecant, we're going to have to type a 1 over sine. So 1 over sine, and then of 210 degrees. See what we get there? We get a -2, and that was a requirement. We can also test 330, so 1 over sine of 330 degrees. And that gives us -2 as well. Okay, so that looks good. And then finally, for example 3, if we check it, we have cosine of 135. So let's see. Cosine of 135 degrees gives us this -0.707. To check that it truly is this negative radical 2 over 2, we can just plug that into the into the calculator as well. So negative radical 2 divided by 2 is the same number. That means that both of these are equal, right? So that means that this angle here of 135 is correct. And we can check 225 exactly the same way, and there it is. Same value for all three. So that looks good. Okay, so that was example number 5. Let's take a look at example number 6, which has 3 parts. For this one, they're asking us to use the unit circle to help us find sine of 720 in part A. And give me just 1 second, guys. Sorry, I'm going to go ahead and close the door because I think there's quite a bit of noise going on outside. So sine of 720, and here's the unit circle. Now, on here we only have angles between 0 degrees and 360. So what that means is that we need to find out what is 720 coterminal to in the range 0 to 360. Okay, so let's work on that first. If we take 720 and divide by 360, okay, we're going to get that it's 2, but just to prove it to you, 720 divided by 360, that's going to give us 2. So this is 2 times 360 plus 0 degrees, and the reason why I'm writing it in this way is because this remainder is going to tell us what the coterminal angle to 720 is. Okay, so 720 is coterminal to 0. That means that we are looking at the point 1, 0 for whatever trig function it is that we're trying to find. In this case, they're asking us for sine of 720. So that means that sine of 720 is the same as sine of 0 degrees, which according to this would be 0. Any questions there? Then we can move on to cosine of 1800. So the first thing again is to try and find the coterminal angle to 1800. So we'll do 1800 divided by 360, and that gives us exactly 5. So it's 5 complete cycles, which would then give you a remainder of 0 again. So that means that 1800 degrees is the same as 0 degrees. So finding cosine of 1800 is the same as finding cosine of 0 degrees. And if we go to the 0 degree mark, the cosine would be the x coordinate. That would be 1. So here we get 1. And last one, tangent of negative 450. Okay, so negative 450, we want a positive coterminal angle. Yeah, so in this case, what we'll do is we take, if you recall, I think, I don't remember if it was for this section or my Wednesday section, but we said when you take 450 and divide by 360, and in this case, we're doing a negative. Instead of writing this as 1 times 360 plus some remainder, we're going to go up higher, okay, to the next highest integer, which is a 2. And it's going to be the negative 2 times 360, because then that means that we're going to have to add something positive onto this number to bring it down to negative 450. As it is right now, negative 2 times 360 will give us a negative 720. So we want to take 720 minus 450, and that'll be a 270. So that means that negative 720 plus 270, and I'll just show you guys on the calculator. That gives us the negative 450 that was given to us. Okay. So what that means then is that the negative 450 is coterminal to 270. So we get tangent of negative 450 is the same as tangent of 270. Now we can take a look at the unit circle. Here is 270. Tangent is going to be y over x. So we're going to have a negative 1 over 0, which means that we're going to have undefined.
I'm sorry, can you repeat how you got negative 2 from when we did the negative 450?
Yeah, so what we want to do is we want to find what's coterminal to negative 450. So think about what we would do to find that. first of all, because we have negative 450, that opens clockwise, right? So it would be one complete cycle that brings us to negative 360 plus some additional degrees more. So 360, that would be what? Negative 90 degrees, so up to here, up to that point. Now, we don't want a negative angle, we want a positive angle. So what we do is say, okay, from the picture, like maybe from the picture it's kind of easier to pick out. We could see that if I take this angle, that's going to be coterminal to the negative 450. Okay, so we think about what's the process to get that. And that is, well, if this were to continue and complete the 2 cycles, we would have negative 2 times 360 to complete it. But then we don't actually make it all the way to completing that second cycle because we are stopped by these 270 degrees. And so that's where that comes from. Sometimes with the negatives, it's easier to see it from the picture, but if you don't want to draw the picture, then you can do it just algebraically. And the process is take the 450, divide by 360, and we get a 1.25. So you find the next highest number, which would be the 2, right? The next largest integer would be the 2. And that take that 2, make it a negative, so that's how we're getting negative 2, times 360. This will give you a negative 720, which means that we're going to have to add something positive onto this number to get the negative 450. And that positive number would have to be 270, which we've written here, because added together they give you this. But yeah, that's how you solve that problem.
I just got a quick question. So I entered tangent 270 and it came out never mind, I just figured it out. Never mind, my bad.
Okay, that's okay. Yeah, no worries. Yeah, so tangent of 270, if you plug it into the calculator, it should give you an error. That's because we have undefined. And then if you type in tangent of negative 450, it should give you exactly the same thing. If we try tangent of negative 450, it tells me I have an error.
On my professor, on my calculator, it gives me something completely different, and it's done it for a few other ones as well when I plug it in on my calculator.
Okay, so what might be happening is that, do you guys remember how we said there are 2 different ways to measure an angle? We can measure it in degrees or in radians. Your calculator can be in one of those 2 settings. It could either be using radians or it could be using degrees. So if you don't have the degree selected, if you have radians selected like this, and again, it's going to look differently depending on what calculator you have. But if you're in radian mode, then when you perform that same calculation, what is that we had? We had tangent of negative 450. We're not going to get the expected result. We're going to get something different. That's because,
okay.
yeah. Yeah. So on your, are you using a graphing calculator or scientific?
It's the exact same one as yours.
Exact same one? Okay, yeah, good. So then for the exact same one, you go to second, and then, sorry, not second, you just need the mode key, and then you choose degree here instead of radians. And then you can do second and then mode again to go back to the main window.
Okay, perfect. Thank you so much.
No problem.